Good morning friends. Today I am going to explain what is Poynting vector and the derivation for it, that is P is equal to E cross H. This is one of the important topic in electromagnetic induction. So Poynting vector means a vector which gives the represents or gives the propagation of energy in electromagnetic waves, and this is also calling as Poynting theorem also. Here first of all, what is electromagnetic wave? Electromagnetic wave means a wave in which the electric and magnetic fields are perpendicular to the direction of propagation. What is Poynting vector? Poynting vector is the vector which gives the energy flow in electromagnetic waves. Okay, so here the definition for this Poynting vector is nothing but a vector which describes the magnitude and direction of the flow of energy in electromagnetic waves, and this is represented by a letter P is equal to E cross H, where the Poynting vector or the energy flow is perpendicular to both electric field and magnetic field. Okay, so here the definition of this one is the amount of field energy passing in unit time through unit area of the surface perpendicular to the direction of propagation of energy is called the Poynting vector, and this is represented by or denoted by letter P. Okay, now the derivation for the P is equal to E cross H. P is the Poynting vector, E is the electric field, and H is the magnetic field. Here the Poynting vector or energy flow is perpendicular to both electric field and magnetic field. We have to prove this theorem. Okay, to prove this one, let us consider an elementary volume in the form of a rectangular parallelopipe of sides dx, dy, dz as shown in this figure. So let us take a parallelopipe that is in rectangular shape, and whose volume of this rectangular parallelopipe is can be given as dv is equal to dx, dy, dz. We know this one. So the volume of the parallelopipe is dx, dy, dz. Suppose the energy is propagated along the x-axis. Now the area is perpendicular to the direction of propagation of energy. So we know that the energy is, if it is propagates along the x-axis, then the area will be perpendicular to the opposite one, that is dy and dz. So like that, so area is perpendicular to the energy, sorry, if the energy is propagates along the x-axis, then the area will be perpendicular to the direction of propagation. So that is area is equal to dy by dz. Now the rate of energy flow through ds. Now this through small element, small volume element, this is taken, that is the energy flow or energy rate of energy flow can be given as minus p dot ds. So here minus is taken because the energy is entered into the parallelopipe. Okay, so rate of energy flow normally through the arbitrary surface is given. So this is energy flow through the small area. Now for the whole one, we should have to take the integration of this equation. So the energy flow or rate of energy flow through the whole arbitrary surface is can be written as p dot ds. So that can be taken as equation number 1. Okay, so first of all we have to consider the small surface, and next after that we have to consider the whole surface. Okay, like this, the energy per unit volume associated with the electric field is 1 by 2 epsilon naught E square, and that of magnetic energy per unit volume is 1 by 2 epsilon naught H square. So these equations are coming in electromagnetic induction only when we are deriving the expression for the energy density. So it's just a remembering point or a note for the how these equations we have to write, that is 1 by 2 epsilon naught E square is nothing but a energy density, that is u is equal to epsilon naught E square by 2 is equal to 1 by 2 epsilon naught E square. This is the energy of electric field, and this is the energy for the magnetic field. So total energy will be equal to the electric field plus magnetic field, that is 1 by 2 epsilon naught E square plus 1 by 2 epsilon naught H square. Okay, so now here the energy content in the parallelopipe is can be given as, so here the energy content can be given as du is equal to 1 by 2 epsilon naught E square plus mu naught H square dV. Now the total energy or the energy contained in an arbitrary volume is expressed as we have to just integrate to this one. So integration of du is u is equal to integration of 1 by 2 epsilon naught, both the side integration. So epsilon naught e square plus mu naught h square dv. Now the rate of change of energy is dou u by dou t. We know this one. So dou u by dou t of this equation can be written as here dou by dou t of integration 1 by 2 epsilon naught e square plus mu naught h square dv. Let us take this as equation number 2. Now if this arbitrary volume is enclosed by the above arbitrary surface, then equation 2 and 1 and 2 represent the same quantities. So here equation 2 is also whatever we calculated, so that is also representing the same as that of the equation number 1. Okay, equation 1 is also represent the rate of energy flow, and equation 2 is also represent whatever we calculated, so that is also represents the rate of energy flow. It means we have to equate the equation number 1 and 2. So when you equate these two equation, we will get the equation number 3, integration minus integration of p dot ds is equal to dou u by dou t. Now consider the situation, that is dou u by dou t. So we are going to calculate the value of dou u by dou t. Dou u by dou t is equal to dou by dou t of integration v 1 by 2 epsilon naught e square plus mu naught h square into dv. Okay, so here if you differentiate to this equation, it will be 1 by 2 epsilon naught e square will be 2e dou e by dou t. Then 2 get cancelled, we will get only dou e dou e by dou t. So like that we will get epsilon naught e dou e by dou t plus mu naught h and h square in differentiation will be 2h dot dou h by dou t. 2 get cancel, we will get 2h dou h by dou t. Okay, now we need the values for this. Now we are going to calculate a dou e by dou t value and dou h by dou t value. For that purpose we have to take the Maxwell's third and fourth equations. Now from the Maxwell's third equation we are going to calculate the value of dou h by dou t. Okay, we know that the Maxwell's third equation is del cross E is equal to minus dou b by dou t. Okay, so here we know that b is nothing but a mu naught h. So in this equation simply b value we are going to substitute. So when you substitute the value of b, then we will get del cross h is equal to mu naught dou h by dou t. So this can be written as dou h by dou t is equal to minus of del cross E by mu naught. Let us take this is equation number 5, and we got the value for the dou h by dou t. Now from Maxwell's fourth equation we can write del cross h is equal to j plus dou t by dou t, because we know that del cross b is equal to mu naught j plus dou t by dou t is the Maxwell's fourth equation. So b value is nothing but a mu naught h, mu naught get cancelled, then del cross h is equal to j plus dou t by dou t we get. Okay, again this is the non-conducting media, so j is equal to the 0 and d will be equal to the epsilon naught e. So that's why I wrote here j is equal to the 0 and d is equal to epsilon naught e. So substituting the d value in this, then del cross h is equal to epsilon naught dou e by dou t. Here I wrote this one because the waves are propagating in the non-conducting media, so that's why j is equal to the 0. So finally we got the value del cross j is equal to epsilon naught e dou e by dou t. Then by this equation we can write the value of dou e by dou t. Then here finally I can write here dou e by dou t is equal to del cross h by epsilon naught. Let us take this is equation number 6. Now equation number 5 is dou h by dou t for, and equation number 6 is dou e by dou t. Now we are going to substitute the value of equation number 5 and 6 value in 4 equation. So that is fourth equation is what? That is we need the value of dou e by dou t and dou h by dou t. So substituting the equation number 5 and 6 in equation number 4, we get this equation. So by that equation epsilon naught get cancelled, mu naught get cancelled, then we will get dou u by dou t is equal to del cross h minus del cross h dot dv. Okay, so mathematically we can write this equation. We know that in mathematics del dot e cross h can be written as minus half e dot del cross h minus half h del cross e. We know this equation, okay, by mathematics. Here dou u by dou t can be written as in this form. This total form will be converted into this form, that is minus of del dot e cross h dot dv. So now we know that by the Gauss divergence theorem, this is in the volume. So volume is converted into surface integral. Okay, according to the Gauss divergence theorem, we are converting the volume integral into surface integral and surface integral into volume integral. So this volume integral is here converted into surface. So that's why dou u by dou t is equal to minus of integration E cross H dot ds I can write. Okay, let us take this is equation number 7. Now substituting the value of equation 7, equation number 3. So what is the equation number 3 we have? That is minus p integration p dot ds is equal to dou u by. Now we got the value for the dou u by dou t. So this dou u by dou t value we are substituting in equation number 3. Then we will get minus of b dot ds minus of e cross h ds. Then I can write p outside, then 1 dot ds, e cross h outside, 1 dot ds, then 1 dot ds get cancelled, then we will get p is equal to e cross h. Now here units of p are, that is Poynting vector units are Webers per meter square. So thus the flow of electromagnetic energy is perpendicular to the plane containing the electric and magnetic vector. Thank you. For more videos, subscribe my channel Physics.